Hi, I'm Adam Prout, CTO and co-founder of SingleStore. And today I want to talk to you about why SingleStoreDB is great for real-time applications. This is going to provide some context for some of the later talks we're going to hear today in our developer track about the latest and greatest features in SingleStore. But this talk is more about what SingleStoreDB is already very good at today. So to start off, what is a real-time application? This isn't an industry standard term. You're going to hear lots of different terms. I think they all describe a very similar use case, maybe data applications, maybe real-time analytics, maybe analytical applications. They're all going to describe use cases that have analytical query shapes, so not just simple get and sets, and yet they're going to combine those analytical query shapes with operational requirements, so low latency, high concurrency. They want it to stay online at all times. Because the analytical query is kind of feeding up through an application. So you can consider it faster, fresher, more precise analytics. To make this more concrete, here's an example real-time app. Obviously, it's a generalization. Each app might be different, but you often have data streaming into your database, in this case, SingleStore. The data that's streaming in could be from Kafka, as we show here. It could be directly from an app. The data could be IoT event data. It could be telemetry from another application. It could be market feeds from external sources. But the key thing is that the data is being streamed in as it's being generated. It's not being batch loaded. Once the data is in the database, you're going to want to serve low latency analytics from it. The analytics could be feeding in through an application. It could be feeding in through a dashboard, which is customer facing and so has kind of lower latency requirements. It could be for doing interactive analytics, so analytics at kind of human speed. And to make this more concrete, I'm going to talk about a few examples of real-time analytics in SingleStoreDB's customer base. And so this use case happens across multiple market segments. IoT is a very popular use case, a market segment for this. So a great example here is telemetry coming off of oil wells, and then doing analytics on that telemetry to detect maintenance issues early with the wells, to do profitability analysis on the wells, should we continue drilling, and day-over-day analysis of how the process is going. Another example is in telemetry coming off of cell phone towers and doing analytics on that data to detect quality of service issues early before customers detect them. Fraud analytics is another place where this happens, where you have a stream of potentially purchase information or other events that is going on in a customer account, and you want to detect if there's fraud, if there's something unusual happening on this account. You can see all these use cases kind of involve the streaming of data, and then you want to do these low latency analytical queries on that data. So now, why SingleStoreDB for real-time apps? Well, this is a use case we've been doing for a long time. So some of the earliest customers of SingleStoreDB were using us for real-time analytics, and they kind of pushed us in this direction of building a more general purpose database. Because remember, real-time apps have some of these qualities of analytics. They want to run analytical queries, and they have qualities of an operational system that wants to be lower latency and stay online. And you can see some of the media companies up here, Comcast, Hulu, Disney. They want to do personalization over the kind of live stream of data, what you're watching, what you have watched, what you've seen, which other things you've maybe watched quickly and didn't continue. And they want to pop up recommendations to you. And Uber is very similar. It's also popping up recommendations based on geospatial data of where you've been in the past and where you're going today. So these early customers really pushed us in this direction. And over the last 10 years, we've built lots of capabilities into the product to satisfy these customers. And to make this more concrete, I think there's 5 key areas of the product that we've built things that are great for real-time apps. Today, I'm only going to talk about one of them, and that's kind of universal storage or flexible indexing. There's a blog post that's kind of linked at the bottom there that'll go into detail on all of these areas, but today we're going to focus just on flexible indexing. So what does that look like? Well, or why is that important for real-time apps? Well, as we said earlier, we want to drive down the latency of our queries. And there's not a lot of magic to that when it comes to a database. That means your database needs to query less data to answer the query. It can't scan lots of rows to answer a query. And so how that works in SingleStore is we have a storage design that has the fast scan performance of a column store. So that's what's going to be in your classic data warehouse, your Redshift, your BigQuery. And on top of that gives you the point read and write performance of a row store. This is like your Postgres, your MySQL. And what this ends up looking like is on the right of the slide there. It's called a log structured merge tree. And I'm not going to describe it in too much detail. It's a layered data structure. The top layer is in memory, and the bottom layer is kind of immutable ordered files. There's a link at the bottom to a paper. It's a very recent paper from a few weeks ago even, and that was released and published in SIGMOD, which is kind of the premier database conference for database practitioners and researchers. That describes really how this works. But today, I'm just going to show some of the capabilities and show what it can do as opposed to describe kind of the exact layout of the bytes on the files. So the first thing it can do is give you the premier scan performance of a column store. So in this kind of simple example, we have a trades table with 57 billion rows in it, and we're going to find the top 10 most traded stocks. And we can do that, and you can see on the right there, in 5 milliseconds. And if you kind of extrapolate that out, that's equivalent to scanning 1.3 trillion rows a second. So this is very fast scan performance of a data warehouse, of a column store. The blog post that's linked at the bottom goes into a lot more details about how this works, if you're interested. But this is just kind of a proof point that, hey, the analytical capabilities of SingleStore are best in class. On top of this, let's say we wanted to find the top 10 most traded stocks for a single customer, that we add that customer ID filter. In SingleStore, we can put an index on that customer ID column, and we can speed this query up by 10x with that index. Now, on your data warehouse, on your Redshift, on your BigQuery, you don't have indexes. You don't have this capability. You don't really have the option of driving down your latency. Of course, your operational system, your Postgres, has indexes, but they don't have that fast scan performance we just showed on the previous slide. So this is kind of you can see how the data layout is more flexible in SingleStore, so you can kind of to get both of these capabilities, the low latency reads and your fast scans. Now, on top of this, we also have unique keys on top of the column store. And what this lets you do is insert rows, and if you hit a duplicate key error, there's that on duplicate key update clause there, and that lets you update the row. It's kind of upsert, and if you're familiar with MySQL terminology. And this is very, very rare for a column store. Almost always, if you're inserting into a column store and you want to deduplicate, you have to use another system, another database to deduplicate and then batch load. But this primary key support lets you just stream directly into SingleStore. And if there's a duplicate, you can deal with it as you're inserting. And again, there's a blog post linked at the bottom there that goes into a lot of detail about universal storage. But as kind of a proof point, since there isn't an industry standard benchmark for real-time applications, we wanted to kind of prove that prove to folks that we can do what we say. We ran 2 industry standard benchmarks, so TPC-H and TPC-C. Now, H is an analytics benchmark, so it's 1 terabyte of data, and it's complex query shapes. And so you can see that orange-yellow bar for SingleStoreDB. We compared against 3 other systems, 2 cloud data warehouses and an operational database. And you can see the yellow bar for the cloud data warehouses. It's the same as SingleStoreDB. We can match kind of the premier cloud data warehouses on this difficult analytics benchmark. You can see the operational database did very poorly on this. And so when I say operational database, I mean like a Postgres, MySQL, SQL Server, something isn't designed for analytics. And it didn't fail to run the benchmark. It just ran it very slowly. We gave up after 24 hours. This particular operational database doesn't have a column store. It's not designed for analytics, so it couldn't do it very well. Now, if you look at the blue bar, that's TPC-C. And so that's an operational benchmark. So that's a much smaller data set, maybe 50 gigs of data, lots of point read and write queries, very high throughput. Now, the cloud database on the far right did very well with this workload. It was designed for this workload. SingleStoreDB also did well on this workload. The cloud data warehouses in the middle, you see they have 0 because they just do not have the features to run this workload. They can't run it. The workload requires primary keys. It requires strong transactions. It requires point updates and deletes, which some column stores don't support. Others support them very poorly. So this is kind of a proof point that SingleStoreDB can run mixed workloads. It can run transactions. It can run analytics. And that's kind of a requirement for real-time apps that want to combine these analytical queries with kind of lower latency kind of inserts and also lower latency kind of query performance. So hopefully that provides some context on why SingleStoreDB is great for real-time apps. some of the features we have, and I pointed to many blog posts with more details that folks can follow up with offline. Next up, we've got Director of Product Management, Eric, with 10 new toys for developers in the Summer 2022 Tool Truck. Eric, take it away.
Hello, I'm here to tell you about 10 new toys for developers in SingleStoreDB. And I'm Eric Hanson. I'm Director of Product Management here at SingleStore. And let's talk about some new stuff. I'd like to say that the Summer 2022 Tool Truck is here. And I used to work in a gas station pumping gas in the state of Oregon, where they still pump the gas for you a long time ago. And I worked with two mechanics that were so excited when the Snap-on tool truck arrived that they literally ran down to the truck and you could see the bottoms of their feet, and they almost always bought a new tool whenever the truck came. So I know that you're excited as developers when you get your hands on new exciting tools in your data platform to use. And so that's what I'm going to tell you about today, some new tools that you can use in exciting ways to build applications. So there's a bunch of exciting new features. I'm not going to talk about them all right here, but this is the list of features I'm going to talk about. Some big ones include things like Workspaces and Code Engine powered by Wasm for extensibility with new user-defined functions written in any language you want. And there's a bunch of other new cool features, and we'll get to them one by one. First, workspaces. So the idea behind workspaces is that a workspace is like a cluster. It's a set of hardware that you can attach databases into. You can have more than one workspace attached to the database at the same time. One of them can be read-write and the others can be read-only. And this allows elastic scalability, allows you to separate OLTP from analytics. You're always going to have fast commits. You can update on the read-write workspace really quickly. You can save money because you don't have to over provision. You can spin up a read-only workspace when you need it to handle a burst. So we think people are going to love this, so give it a try. Next, Code Engine powered by Wasm allows you to extend SingleStore with functions implemented in languages like C, C++, and Rust, and they run in the database and you can call them from SQL. So your Wasm module runs in a sandbox in the database, and it allows you to call that code from SQL, which can allow you to do amazing things. Like you can take libraries of existing code or code from your app and create user-defined functions for that and call it from SQL. On the left, there's an example of Levenstein distance as a UDF implemented in Rust. And you can call that from SQL and find like partial matches of license plates, something really practical and there are lots of examples like this for fuzzy matching or partial matching and many more. Next, flexible parallelism. So what is it? In the old days, we had one thread per partition for parallel query processing. Now you can have n threads per partition with flexible parallelism. So you can use all the cores in your system to speed up one query. You can run individual queries faster. The subpartitions are created when the database is created. And this enables elastic scaling, so it fits together with workspaces pretty nicely. Next, automatic MA failover. This has limited availability by invitation only right now. We'll GA it later this year. The basic idea is that if an MA fails, we detect it automatically. We can elect a new one based on a quorum of voting members, fail over to have the MA be one of the other aggregators that was a voting member. This requires premium edition. You need to be running on our cloud. The benefits of this are high availability for DDL, ref table updates, and leaf failovers. And now we can tolerate loss of an MA server or an entire availability zone on our cloud platform. There's no human intervention required. This is fully automatic, and this gives you better overall high availability. Next, computed column matching is a really fun and exciting new feature for developers because people may want to have an expression that's used frequently in a query and would like to be able to speed up computation of that expression and also build indexes on that expression. So for example, You might have a JSON column. You might want to pull a property out of that JSON object and promote it to another computed column. And then you might want to create an index on it even. So now you can do that with computed column matching. Select for update on column store is a new feature that used to only work on row store. Basically, it allows you to do serializable isolation which is useful for certain OLTP transactions by holding locks on specific records until you commit a transaction. So it's good for certain, for example, financial transactions where you absolutely want to make sure that you have serializable isolation. So in the example on the right, you can select a row for update, and that's locked until you commit. So then you can calculate some new value, update it, and then commit, and then the lock is released. And so now you can process OLTP applications on data much bigger than will fit in RAM, because you don't have to use row store for this anymore. You can use column store. Also, we now support set. Set used to be a no-op. Set is for session variables, @ variables. This, funny enough, has worked for many years as a no-op, just so we didn't have incompatibility with some MySQL apps that use the set statement. We didn't want those apps to crash, but they actually weren't behaving as expected because set was a no-op. You could use select into in order to accomplish the same thing, but that was a little less convenient than just using set. So now the set statement works as expected, and I guarantee that many of you will be using this because it's just convenient, and lots of other database products support it. So now we do too. Also, we have new vector functions available, like vector sort, vector element sum, and several others. These complement our existing vector functions, things like dot product, that are used for AI matching. And the benefits are that these new functions are really fast. They enable vector apps in general, and an example is one of our customers wants to use it for a value at risk calculation in the financial industry. They used to have to extract the data into the app tier to do this, and now they're going to be able to do much more of it in the database. It'll be more convenient and faster for them. And value at risk calculation is to help calculate overall portfolio risk to make sure that, like, banks or trading companies are not overweighted in any one sector or company. That's just one example of many that you can do with these vector functions. We now support a HTTP data API. The basic idea is that you can use HTTP to request results from SingleStoreDB, and you get responses back. And it has dynamic connection management. It's super convenient. It supports virtually any kind of client, and it lets you take advantage of this HTTP ecosystem. So for people that are developing mobile and web apps, for example, we think this will be really convenient, more convenient potentially than using other APIs like ODBC, just less code and less connection management. JWT authorization is now also available. Basically, JSON web tokens are used to authorize connections to SingleStoreDB, and a client can log in, get a JSON web token or JWT, and then for the rest of their session, they can log into SingleStoreDB with that token. And so it's a convenient way to handle authorization, and eliminates the use of passwords. So we think this will be very popular. JWTs are very popular for building distributed applications and handling authorization in a convenient way. That's it. Thank you. So try the 10 new toys for developers. We think you're really going to like them. Thank you for listening. Bye-bye.
Thank you, Eric, for that great look at the exciting new features coming to SingleStoreDB for developers. Let's keep things going with Senior Software Engineer Lewis, who's giving an in-depth look at Workspaces, the brand new elasticity feature in SingleStore. Take it away, Lewis.
I'm Luis, and I'm a software engineer based in Lisbon. I've been working at SingleStore in the cloud team for almost 3 years now. Today I want to share with you all some more details about this new exciting feature we have just announced, also known as Workspaces. I will start by explaining what Workspaces are, give some more technical details about them, as well as a demo using our REST API to automate different workloads. So last year, we announced full separation of storage and compute. Basically, without that workspaces wouldn't have been possible today. They are really the foundation, the base of everything. Yeah. But before going too deep, let's first do a very quick recap about workspaces. So as we can see in this picture, their main goal is to provide separation of compute and compute, so you can have multiple workloads attached and sharing the same database inside an isolated environment. So each environment is basically a workspace, so you can run a different workload inside each workspace, and they will have some isolation. So let's say that you need more compute resources on the workspace tree because the workload that you are running there is very heavy. So that's easy to do. You can scale that workspace independently, and that will not affect the other workspaces. That's also true for the opposite thing. So let's say that the workspace 2 doesn't need to be active the whole day. So you are running a workload that only needs to run during some hours during the day. So you can very easily terminate it at night, and then whenever you need it again, like let's say in the morning, you can just recreate it and all the data will be there available. This is very useful because you can save up a lot of money with this. Yeah. At this point, you are probably wondering, so all the workspaces work internally, right? So as I mentioned before, workspaces are only possible due to our separation of storage and compute architecture. In this architecture, we rely on a three-tier storage model composed of memory, disk, and remote storage such as S3. We try to combine these three storage types in a very neat way so we can get the best of all the worlds. So we use memory as a buffer for high throughput in inserts. We use disk for better analytics performance, and we rely on a column store structure underneath, and also remote blob storage, so we can have unlimited storage and ensure that we don't lose any data. So yeah, by looking at this picture, it starts being very clear where this separation between storage and compute happens. So if we would draw a line here, that's where the separation would start. So on the bottom, we would have the databases, the storage, and on the top, we would have the compute. And this compute will be basically cache. So a workspace will be composed by memory and disks. And yeah, these memory and disks are really just cache, as I just said, and this enables us to have faster query processing and ingestion. And also, these workspaces, they don't need to have all the data there. So if you are running a workload that only needs 10% of the data of that database, even if your database is huge, that's fine. The workspace will only need the required data, the portion of data needed to run that query. So yeah, there is also another interesting question that you might be wondering is, how fresh is the data in one workspace? Doesn't relying on remote storage adds a big delay on that? Yeah, it's actually not that long. So because of the way we do separation of storage and compute being so unique, we don't need to wait for an insert to reach the remote storage to mark it as committed and ensure data persistent. We rely on high availability for that. So any new changes, an insert or an update, they will always be transmitted to at least 2 partitions in memory to make sure that we don't lose any data. So yeah, taking that in consideration, we can have replication directly of fresh data between workspace nodes. So this means that the remote storage is very rarely a bottleneck, and also that the replication will be done quite fast. So yeah, if we look inside the workspace, they have a very similar architecture to a normal single store cluster. So they will have their own set of aggregators and leaves. So this means that a workspace is isolated workspaces are isolated between each other, and that you can add more aggregators and leaves to one workspace without affecting the other workspaces because these nodes, they are not shared between each other. So it's time for a demo and see workspaces in action. I will be mainly using our REST API to create workspaces. So first of all, in order to use this API, we need to create a new key. and this key will be an authorization token to access this API. So in order to do that, we can access the portal SingleStore UI, and in this UI, you will have a section to manage and create new keys. In this case, for this demo, I will be using an existing key that I created before. And I already have a bunch of curl commands prepared. So this first command will create a group. And we first need to create a group because we need a wrapper to workspaces and databases. So basically, databases can only move between workspaces that belong to the same group. So let's do it. Okay, so a group was successfully created. So let's now try to create two workspaces. We just need to make sure that they are created inside the right group. So let's point to the right ID. So the first workspace was created. Let's create the workspace 2, demo 2. And yeah, so now we just created two workspaces inside the group. So yeah, if you need to check like all the operations that we support, you can refer to our docs. There is an API reference page, and this page even helps you to generate the curl commands if you just want to play around with the API. And you can just come here and play around here with the parameters, and all the commands will be generated for you. So yeah, let's now take a look at the UI. And yeah, here you already have a dashboard with the resources that we just created. So you can see two workspaces here, demo 1 and demo 2. So we can try and now load some data into one of the workspaces. So let's just use our tutorials for that. And here we can take advantage of some sample data that we have. So let's load some stock trades data. And yeah, let's try to load it to the demo 2 workspace. So let's try it out. Yeah, this usually takes around 20 seconds to finish. But yeah, in the meanwhile, we can create another database, empty one. So yeah, now we have a workspace with the data set the sample one, and the other workspace has an empty database. So we can also now attach this sample dataset to the other workspace. So yeah, now both workspaces have access to this database. So you can run different workloads in them, and they can be sharing and reusing the same data. So let's give it a try. Let's go to the SQL editor and try to run some queries against it. So the tutorial already provides you some useful queries. So let's try this one, that it basically finds the most traded stocks. And now we are running it against the demo 2 workspace. Yeah, we can see that it was quite fast. And now we can try to run that same query in the other workspace. And that workspace will still also have access to that database, and they will both return the same results. So yeah, that was everything I had to show you today. I really hope you are all as excited as I am about this new feature, because it really makes new use cases that we couldn't do before possible. So that's super cool. And yeah, if you have any questions, just let us know in our forum. You can access it at forum.singlestore.com, or if you want to try Workspaces out, just go to our portal.singlestore.com, and create a new account and just play around with them. So cool. So really thanks for your time.
What a great look at the demo of Workspaces. Thank you, Louis. We've got more great feature deep dives. Let's hand it over to Peter, a senior software engineer from SingleStore's Launchpad team, to talk about Code Engine powered by Wasm, which we believe is the first production integration of Wasm into a SQL relational database. Over to you, Peter.
Hello, my name is Peter Vetere, and I'm a software developer on the Launchpad team here at SingleStore. For the past several months, my team has been adding support for WebAssembly UDF's to our database engine. We've just released our first production version of this feature, and we're excited to share with you how it works. In this talk, I'll walk you through a simple but practical example. We'll discuss certain design considerations, and then explore a possible development workflow. WebAssembly or Wasm for short, is a compilation target now supported by many programming languages. While traditionally browser-oriented, it is increasingly finding utility on the server side as well. Its design is focused towards security and performance. As well as being language agnostic, these characteristics make it ideal for writing server-side plugins. Indeed, this is what inspired our choice to introduce support for Wasm in our own database. User-defined functions, or UDFs for short, are a common way that databases allow users to add custom logic to their queries. Until now, UDFs have only been possible in SingleStoreDB through our proprietary dialect called MP-SQL. As we'll see, however, Wasm UDFs bring our engine's extensibility to a whole new level. When designing a Wasm UDF for SingleStoreDB, there are some important factors to take into consideration. First, Wasm UDFs in SingleStoreDB can only return a single value, not a table. While we do also have some support for table value functions in our first release, this is still experimental, and we'll remain focused on UDFs for this discussion. Second, Wasm UDFs are passed values directly from the database engine and do not use an iterator abstraction. This means that, for now, a Wasm UDF is only aware of one row at a time, and exactly one output row must be produced for each input row. There is no intrinsic state kept between calls. Third, you'll need to consider your interface types when choosing your programming language. If your Wasm function only passes numeric information, then it may be written in any source language that compiles to Wasm. For more complex types, such as arrays, records, or strings, SingleStoreDB currently only supports Wasm UDFs compiled from Rust, C, or C++. Now let's dig into a practical example. I found this interesting data set on Kaggle.com. It consists of 3 million headlines collected over a couple of weeks from thousands of different news feeds from all over the world. I thought it might be interesting to learn which news sources are the most active for any given language. To do this, we need to have some way to identify the language used in each headline. This information is not provided directly in the dataset, but fortunately, there are some great language detection algorithms out there. Unfortunately, these algorithms are not trivial, and it would take a significant amount of time to write one from scratch in MP-SQL. Now, this is where the power of Wasm really shines. Since we now have the ability to write our UDF logic in Rust, we instantly have the vast catalog of pre-written libraries on crates.io available at our fingertips. This shouldn't take long. After some research, I've settled on a great language detection library written in Rust by Sergei Potapov. It is called WhatLang and has a nice clean API that will make it easy for us to wrap it up. Now that we've decided on a library, we need to describe our Wasm function's interface to the database. To do this, we'll make use of an emerging IDL syntax standard called WIT. WIT allows you to define your Wasm function's interface in a language-agnostic way. You can then pass your WIT specification to a binding generator to help you generate a Wasm module capable of handling complex types. Here is our WIT file. It's pretty simple. Now let's look at the implementation. Here we go. Thanks to the power of reusability, this is all of the source code we need to accomplish our goal. And the top part is actually just boilerplate code required by the binding generator. The bottom half contains a definition of a function I've named guessLanguage. This is the function that we will be surfacing to the database through the UDF. It basically just wraps the WhatLang API function called detect. Now to compile it. At the very least, we will need the Rust toolchain, WASI libraries, and the tool that generates the WIT bindings. Fortunately, SingleStore has developed and open-sourced a development container with all the dependencies you need. We just need to give it our project directory. So just a minute while I switch desktops to demonstrate. And here we are. Compiling is simple. We just need to make sure we indicate the Wasm32 WASI target. And we can now find the resulting Wasm module down in the target directory. Now let's do some unit testing. To help with this, SingleStore has open sourced another useful tool called RIT for WASI Reactor Interface Tester. We can use this tool to easily run a batch of inputs through our function and examine the outputs, or see if it crashes. It is much easier to do this kind of testing before deploying the function to the database whenever possible. I've already taken the liberty of preparing a collection of headlines for testing. Let's see how they fare with our tool. Uh-oh, looks like we found a bug in the code. This message indicates that the error happened on line 8 while trying to unwrap a none value. Also, it appears that an empty string was being passed in. Let's go back to the code. Yes, it appears that the empty string is an invalid input for the detect function. There are a number of ways to handle this problem, but for simplicity, let's just return empty values when this happens. To save time, I've already made the changes here. Now let's go back to our shell and recompile so we can try again. And once again, rerun our tests. There we go. No errors. Great. Now let's deploy it to the database. As you can see, SingleStoreDB gives us a few different ways to do this. For this demonstration, we'll use a GCS bucket to host the module and have the database pull it from there. Again, to save some time, I've already done this part. Let's go to the query editor on the SingleStore portal to finish the deployment. This database already has the headlines dataset loaded into a table. We can see the schema for it here. All we need to do now is import our Wasm module from GCS. We'll do this using a variant of the existing create function statement. Since we used a width spec to define the interface, we'll also pass that in as well. Looks like it imported successfully. The database was able to infer its own native types from the types we declared in the width file. For now, SingleStoreDB only supports non-nullable types with Wasm UDFs, but we do plan to add support for nulls in the near future. Let's run a very simple query just to see what the UDF is actually returning to us. We'll use a sample of 10 rows. In the left column are random headlines from the dataset, and in the right column, we see the JSON representation of each corresponding prediction record returned from the wetlang library. In SingleStoreDB, converting a record to a JSON string is one way for us to easily see its contents. Now, before we wrap up, let's follow through on the question I posed at the beginning of the talk. We can use our UDF to construct a query that will find the most active news sources for, say, the English language. This may take a few moments. During this process, the database is executing our Wasm function many times in parallel, and it's happening from inside the engine's actual process. There we go. Interesting. It looks like the World News Network is by far the most prolific of the bunch. This makes sense, since they are largely a news aggregator and republish articles from thousands of other sources. Although this was a relatively simple research project, I hope I have been able to show you how Wasm UDFs can open up an entirely new dimension of analytic possibilities for your organization, and with only a small amount of effort. It will be exciting to see how this technology matures in the coming years as Wasm becomes more and more entrenched in our technical lives. I'm thrilled to have been able to play a part in bringing this feature to you, and I look forward to learning about the interesting and creative ways you may find to use it. On behalf of the Launchpad team here at SingleStore, thank you so much for tuning in. We'll see you next time.
Thanks for walking us through Wasm, Peter. As we continue with our focus on all things real-time, I'm excited to introduce Amy, Partner Engineering Manager at DBT, and Julie, Senior Product Manager at SingleStore, to take you through how to power real-time applications. Julie, Amy, take it away.
Hello, everybody. I'm Julie Price. I'm a Senior Product Manager here at SingleStore, and I'm joined by Amy Chen, who is from DBT Labs. And we're here today to talk to you about how SingleStoreDB and DBT can really help to supercharge your real-time analytics and give you a great tool to have in your arsenal to use for building out your analytics transformations. So Amy, why don't you tell me a little bit about yourself and about DBT Labs?
Thank you so much. Hi, everyone. I'm Amy Chen. I'm the Partner Engineering Manager here at DBT Labs. In case you aren't aware of what DBT is, DBT Labs is essentially the creators and maintainers of a tool called DBT. Now, what DBT is it's a transformation workflow that essentially allows anyone who's comfortable with SQL to create trusted data pipelines. How I like to think about us is we are a SQL first product that our main goal is to essentially give folks the ability to test, document, version control, and create modular code for your data pipelines. And we do that with a SQL first mentality. We have two key offerings, which is DBT Core, which is that open source framework, as well as DBT Cloud, which is the fully managed SaaS product that gives you an optimized DBT workflow from development to deployment. Now, Julie, we have known each other for, I think, about a year, and what kicked this relationship off was essentially you decided to build a single store DBT adapter. Could you tell us a little bit about why you decided that?
Yeah, absolutely. So I've actually been in the data and analytics space for a long time. I started hearing rumblings about DBT probably back like right when the product was launched and when the company had a different name and everything. And so I started to notice this momentum and a lot of adoption and actually that you created a term called analytics engineers, which is really amazing. And so I started to see that, it was so widely adopted by analytics engineers and really commonly adopted in the data warehousing space. And Single Store is really good for data warehousing, but actually like the reason why people really adopt SingleStoreDB is because of the ability to do transactional and analytical processing together in the same database, not just on the same database, but on the same table even. And so that's really powerful. And so we see a lot of developers adopting SingleStoreDB. And so one of the things that really attracted me to DBT for SingleStoreDB is kind of the developer centricity of the DBT tool and the ability to do a lot of the things that developers want to do. And now you might think like, if I'm doing analytics on the same table that I'm doing transactions on, why do I even need DBT? The reality is that most of the time, all of the data you need for analytics is not in the same table. Most of the time, the column names, the calculations, the expressions, like those types of things aren't really handled, and you still need to do those transformations. And so although we don't necessarily want to go through like a batch process to materialize transformations, DBT is really powerful also for creating views. So you can create your models, which result in SQL views. And a lot of times those views are depending on other views, which are depending on other views and other views and other views. And that's really complicated. And so a lot of what DBT brings to the table for that as well is the concept of observability or discoverability on like what the dependencies are of the various different views. So if I'm a developer and I go in and I change something, I actually know what I'm going to break. And I spent a long time in my career actually figuring out what I just broke. Sometimes it was weeks to figure that out. Back when I was doing data warehouse development. So that's one of the big reasons. And, as I mentioned, developers really want the same controls for their database objects as they have for other development assets. So they want to be able to build, test, document, and deploy, have version control, all of that kind of stuff. And so I think DBT is just a really, really powerful tool to include in your development toolkit when you're working with SingleStoreDB. And that's why we built it. So is that kind of aligned with what you see within your community and usage of DBT as well?
Definitely. So one of the things that we often get asked is like, why can't I just write this transformation in the UI? Or like, why can't I just do this on my own? But the benefits of DBT isn't so much like helping you write that transformation. That's the easy part. That's the part you're actually being paid for. But it's really much about the overall framework. And we have been known to have very opinionated best practices because we have learned from years of just being in the industry about how to minimize your tech debt. How, if you accidentally lose lineage, like what is a truly optimized workflow? And I think while you could definitely technically build this all yourself, with DBT, you just get all those levers out of the box. And on top of that, we have the community that really keeps us pushing to create more. And if it's not there, they'll let us know. And also, if better yet, oftentimes they'll just create it and contribute it to the DBT product.
Yeah, so speaking of the community is actually one of the things, it's one of my favorite things about DBT. And it's part of the reason why also that we looked at creating DBT adapter. We had people in the Single Store forum, so come in and say, hey, are you going to support DBT? Will you have an adapter that supports all of the cool Single Store stuff that you have, like shard and sort keys and things like that, which we now do support in our DBT adapter. That being said, like, why is the community so passionate about DBT? Like, I know that the community brings databases to you often. So why is that?
Yeah, I love in DBT Slack where someone's like, hey, do you support this? And then if not, we'll usually reverse it back and like, do you want to build an adapter? And when they say yes, it's like pretty epic. And I think the reason why we've set up this kind of conversation is essentially because, one, we are open source. So by its essence, the open source mentality often means that, like, if you use the tool, there's an expectation that if you love it, you will contribute back. And this sounds a little bit marketing centric, but like when we talk about the community, we at DBT Labs think of ourselves as more like the maintainers, but we're part of the community, and it is not our community. We want to make sure we're facilitating those conversations, so it's easier to contribute, like lower the barrier entry to maybe you're an analyst and you have a good solution to an adapter and you believe this is the right way to do a workflow, then there should be no barrier for you to open a PR and start that conversation. So I think what's key here is like the DBT community, I joke a lot, it's just extremely nice. And that's because a lot of times we've set into that space to leave your ego at the door and ask your question, even if it might feel silly. And this often creates that flywheel of enjoying being there rather than just coming to ask the question and then leaving. We see a lot of folks just bring in their friends and be like, you got to go check this out, because it's a place to have open dialogue.
So I mean, like I said, the community is one of my favorite things. Can you tell us, first of all, how we can find the community?
So if you type in community.getdbt.com, you'll get access to our community site, and then there's a link that you can fill out to get access to our Slack community. But I want to emphasize our Slack community is not the only part of the community. We have lots of folks just writing blog posts and stuff, but if you want ease of dialogue, there's 30,000 folks who are excited to chat with you.
Awesome. And one of my favorite places is the memes and off-topic chatter. So if you just need a good generation of memes, check out that Slack channel.
Now I have to ask, what's up next for SingleStore and DBT? Are you about to make any memes about SingleStore and DBT?
Oh, well, I mean, challenge accepted. So give us a few days on that. But so specifically for the SingleStoreDB DBT adapter, there's a couple of interesting things that we have in the works. One, we support all of kind of your traditional database objects, tables and views, and support the SingleStoreDB specific constructs for those, like shard and sort keys and things like that. One of the really interesting requests that we've recently had from the community also is to be able to support pipelines. So SingleStore pipelines is an integrated way to actually ingest data streaming or in batch into SingleStoreDB without any other like third-party tool. And so that's pretty amazing. So being able to manage the creation and adaptation of pipelines is one. And also folks on the other launch recordings would have heard that we've recently launched something called Workspaces, which is giving you the ability to like greatly scale out your compute resources against the same set of data. And so integrating things like having our Workspaces API that enables us to, spin up and spin down the workspaces through the DBT adapter. So I think that that's pretty exciting stuff that we have going on. And I imagine that DBT is not done making updates either. So what are you up to and what are you excited about?
Yeah, I think the spiciest thing that is starting to come up is that while DBT is always going to be a SQL first product, we're starting to expand to support Python. So we're really excited for that, and you'll definitely hear more, especially if you join us at our conference, the Analytics Engineering Conference named Coalesce in October. Outside of that, as always, we're trying to expand all of the offerings that folks are interested in. So I definitely hope to see SingleStore as one of the adapters in the near future on DBT Cloud.
Awesome. So for those of you who are listening, if you want to learn a little bit more about DBT, about SingleStoreDB and our adapter in particular, you can go ahead and just type in SingleStoreDB and DBT into Google search. You'll get both the DBT documentation around the SingleStore profile, how you get it set up and everything like that. And you can find more information also out on SingleStore's site, including some blogs and other information as well. So Amy, I really appreciate it. It was awesome getting the chance to catch up with you today, to give the folks watching an introduction to kind of what DBT is and why we built the connector. So I just want to say thanks so much to you, and thanks so much to everybody who's watching.
Thank you so much, Amy and Julie. We're rounding out our track today with a bang as we take on breaking data barriers. Please welcome Jorge, co-founder and CEO of MindsDB, to talk about the company's inception as an open source in-database machine learning platform. Jorge, over to you.
We believe that data and leveraging data to make informed decisions is the best way to get a competitive advantage. And machine learning plays a crucial role in this process. MindsDB and SingleStore together enable companies to accomplish exactly that. My name is Jorge Torres, and I'm very excited to present to you this partnership that we have with SingleStore and MindsDB, and a little bit about MindsDB as a company. We started MindsDB as an open source project back at UC Berkeley in 2017. Then we went to Y Combinator in 2020. We raised a decent seed round to make sure that our open source project, which is a very mature open source project, got to the level of maturity that could be used by large organizations. And we're one of the most promising AI companies by Forbes, truly because this different idea that we have about making sure that companies can get to production as fast as possible when they actually have a machine learning problem in mind. And this of getting into production as fast as possible is possible because of the fact that if your data is in a database, you've already accomplished the most difficult part of any machine learning task, the data preparation task. Now, in a data-centric approach, the database is the heart and the beating heart of your infrastructure and of your decision-making process. Connected to your database, you have the analytics, the applications. You already figure out how to stream data and pipe data into SingleStore, and you already know how to organize it. So since you've already cracked this very difficult part, the goal of MindsDB is to ensure that you can do the modeling and the deployment in a very similar environment to the one that you have for processing data in the database. So it allows you to do everything in SQL. Let me walk you through a demo that will show this end to end. The way that MindsDB works is that it is a database for machine learning models, yet everything that has to do with data, it delegates to the database, in this case, SingleStore. We're going to connect to our SingleStore database and do some sort of modeling and predictions. Now, in this particular demo, we're going to have house rentals data, and we're going to forecast this into the future. This is a really cool project because it's also a difficult one for machine learning, where you have a time series problem that has a high degree of cardinality, and it's also multivariate. Let's look at the data and explore and see how and why that is the case. So what we have here is data quarter by quarter, and it has some attributes. It has a moving average of the price, which is what we want to predict, but also it has the type, which it can be a house or it can be an apartment, and it has a number of bedrooms. So essentially what we're going to do here is, okay, for a house, roughly in the area of San Francisco, what will be, or in the area of Berkeley, what will be the price in the next following 3 or 4 quarters, taking into consideration all the information that I have of the moving average of all the prices that I can collect. Let's see how we can actually create a predictor for this. The beauty of MindsDB is that it abstracts all the life cycle for machine learning into one single statement. You have the data preparation, which is a query in this case. This query can be as complex as you want. For the sake of this example, it's a simple query, but if you need to do any form of data transformation, you can create this query here, put this query statement here, and that gets delegated to SingleStore. On the other hand, if you want, you can create a view that creates all the transformations in SingleStore, and then MindsDB queries that view. Now, the create predictor statement is similar to that of create a table, and it does a modeling part. And in the modeling part, what you're doing is, okay, I want to do a time series problem that orders by sales date. Essentially, that is the horizon, or that is the column that contains the information which you're going to order information by. And then this one is a multivariate high partition or high cardinality problem because it has many different, number of bedrooms and number of types of property. And at the end, what you're telling is, I want to order by, group by these two attributes, and I want to be able to take into account the last 8 quarters in order to project the next 4. Let's run the statements. For the sake of this demo, I had already trained the model before, but I'm going to run this one. And so we don't have to wait until the model is done training. We can actually look at how the model performed in the last. Let's check out the model that I had trained. Now, what it's telling me is this model has a 52% accuracy across the 4 periods. So like it will get better, or the first result in the first quarter has a very good accuracy. And as the time progresses, the accuracy will drop. Still 55% is good, taking into account that you're trying to forecast something a year in advance. So let's look at how the model was built. This model was built using a neural network, LightGBM and SK-time. And then MindsDB will try those and figure out which one will be the one that performs the best. In this case, SK-time is the winner, and that is how the model was being put together. Now, you may be asking, okay, but what data was put into the model? How do you encode this data? MindsDB gives you this trick, which is the ensemble. You can dive into how that ensemble was built, and you can also experiment with it. You can change how and which parameters you want. Even if you wanted to use only SK-time, or if you wanted to use a transformer, you can specify this capability on the create predictor. But let's look at how the ensemble was put together. So MindsDB realized that the moving average is one of the time series columns. So it's going to encode it as numeric values and code it into another array. The same thing for sales, date, then the type. It realized that, well, you only have 2 categories here, so let's put in a binary encoder. The number of bedrooms, let's do a 1-hot encoder. And then at the end, it decided that it was going to try a neural network, LightGBM array, and SK-time. Well, now, having said that, now you can query the model as if it was a table. Since this is a time series model, you can join it with the data that you have. Let's actually make a query to predict what would be the prices for the houses when the bedrooms are 2 in the next following quarters, and for the date greater than the latest. This is a unique statement to the way that MindsDB does things, which is, well, you actually want to forecast something into the future, assuming that the latest data point is a data point of today, then the latest 4 would be the next 4 quarters. And that is crucial to forecasting. And we make this simplification. So when you run the query, you don't have to go and fetch the last 4 or the last 8 of properties that are houses and number of bedrooms too. MindsDB does this kind of like organization for you. Let's make this prediction. Okay, and there you have it. Forecasting for the following 4 quarters given the latest information. Thank you so much for being part of this demo, and looking forward to see what all of you can do with MindsDB and SingleStore. And before we're done, some resources for you. You can get started with SingleStore. There's a 500 in free credits today. Follow these links. Also, there's a very comprehensive guide for anyone that has any questions about SingleStore. Go to the SingleStore download and start using the product. And for MindsDB, you get the cloud account for free as well. We, of course, are open source project. You can deploy it on your premise, but you can go to cloud.mindsdb.com and you can get started within a few clicks. Join our community, GitHub, Slack. Looking forward to see you there. Thank you.
Thank you again to our engineers for giving us a closer look at the latest features in SingleStoreDB, as well as our incredible speakers for sharing their take on powering real-time applications. I hope you've enjoyed this breakout track for Revolution 2022. If you missed any sessions or would like to watch them again, you can find them on our SingleStore YouTube channel. If you can't wait to try these new features in SingleStoreDB, click the link to get started with your free trial, including $500 in free credits for our managed service.